like that, so that we can have a clear picture who plays an important role why this concept arrived or evolved. Okay, through constant evolution of different experimental analysis with regards to radiation, they come up with this type of forces, the weak nuclear forces and the strong nuclear forces. And then through this, we can understand further the radiation, the electromagnetic radiation, and the nuclear radiation, something like that. Okay? Get the point. Ganon. Okay? So, the first who discovered radiation or radioactivity is Mr. Henry Becquerel. Okay? Mr. Henry Becquerel. Oh, ganon. Diba? Becquerel. Okay, for the radiation. Okay. The second group or team talaga siya, diba? I think mag-asawa silang duha. After the Henry Becquerel discovered originally the radiation or radioactivity, so here comes another individuals. I think they are husband and wife. I'm not really that sure based on my memory only. They are Pierre Marie Curie. Pierre Marie Curie. Okay. Pierre Marie Curie. I think this Pierre Marie Curie, I don't think so if it is really a couple or one guy only. Guys, this is too long ago. Okay, I was third year high school for this. Okay, today is 2022, right? I think this is somewhere on 1992. Okay, how many years? 2022 minus 2022 minus 1992. Guys, it's already 30 years that I studied this chemistry in high school. This is the time when I memorized these scientists. Okay? 30 years. Okay? Then I could still remember. Okay. So Pierre Marie Curie discovered the radiation. As far as I can remember, that is a polonium and radium of the experiment. Polonium and radium. Okay, something like that. These kinds of elements will do radioactive decay and can be useful to the community, like that, whatever. Okay, and then I think so also they received the Nobel Prize. Nobel Prize. Okay, it's not Henry Becquerel or receiving the Nobel. Just correct me, mga panggaha, because it was 30 years ago. Maybe I'm wrong. Okay, just correct me if I'm wrong. Okay. But I'm pretty sure it's gonna be Henry Becquerel, the first to discover radioactivity. Second lang sila si Pierre Marie Curie. Okay, get the point. Now, we have two types of radiation. If you are familiar with this, two types of radiation. I think this is also discussed in the subject of particle physics. Okay, actually there is also a subject known as particle chemistry, but this is more discussed in particle physics, meaning we are really studying more on the particles. We need to get to have samples and we need to analyze in the laboratory, something like that. Okay, you get the point? So our life is always in the laboratory because we have a lot of laboratories. Okay, in chemical engineering, always experiment, science experiment, like that, blah blah blah, so and so. Okay, so two types of radiation. Okay, ganon. What are those? We have the electromagnetic radiation. Okay. Electromagnetic radiation. And we have also the nuclear radiation. Okay. Which is more fatal or fatal in your own analysis? Radiation. Would it be the nuclear radiation or the electromagnetic radiation? Think it over. Okay, so in your second type, if you mention this nuclear radiation, what comes on your mind is a nuclear reactor. Okay, and then with a nuclear reactor, if mismanaged, it will explode. Okay, just like the Chernobyl chemical plant in Japan, and also somewhere in India, I cannot remember the place, and it exploded because of this nuclear radiation, the nuclear activity that was being mismanaged and taken for granted, the chemical reactivity. Okay, you get the point. So you should be careful if you are trying to be assigned in a nuclear reactor as a process. Okay, nuclear engineer. Nuclear talaga siya, specific, right? Okay, ganon. Ang electromagnetic, pili kayo siya, guys, because it's more on the, for example, sound wave, radio wave, microwave, infrared, ultraviolet rays of the sun, and the colors. Colors also we see in our eyes are also radiation. Get the point? So we need to correct the concept that if we see a color like green, yellow, it's not a radiation, it's still a radiation because it will emit a particle. Okay, and after emitting a particle, that could have the desired frequency and wavelength, particularly, for example, red, blue, then we can see the red appearing. If these requirements for the color orange will not meet the wavelength values, for example, I don't have to be specific, I cannot memorize everything about that also. Okay, it takes a lot of time. Though it's already in my brain cells, but I cannot do one by one. Okay. Okay, for example, orange. It will not appear orange if this wavelength value and frequency value will not be attained, will not be achieved. So all types of colors, red, like that, orange, yellow, green, blue, indigo, and violet. The sequential colors or arrangement of a rainbow. Roy beef. Okay, red, orange, yellow, green, blue, indigo, and violet. Okay, something like that. These are visible rays. Okay, meaning still a radiation, but with a lower frequency or low energy release, something like that, compared to the X-rays in the hospitals and different types of CT scan, that one, the computerized tomography process in hospitals, and also the MRI, the magnetic resonance imaging, to determine if your brain have tumors, then you have to do the scanning through MRI, magnetic resonance imaging. And you have also, for example, if your wife is pregnant, like that, ultrasound. Okay, ultrasound is also the process of radiation. It's gonna be like that. Okay, so it's under in this topic for this subject for particle physics and particle chemistry. Okay, ganon siya. Okay, now, electromagnetic radiation falls into the electromagnetic waves. Okay, electromagnetic waves. Okay, so in this concept, we are trying to emphasize that all kinds of radiation that fall into this first type are obeying the particle and wave duality. Meaning it can act as a particle and sometimes also can act as a wave. So we need to say both wavelength, the distance covered, and also the amplitude. The height covered, just like a spiral, something like that, and then we have also the frequency. Okay, these are the three requirements so that the electromagnetic waves will be moving from point A to point B, blah blah blah, so and so. Okay, this is electromagnetic waves. Example for this is the light energy. Light energy, that's why I said yellow, blue, because the light colors, right? Light energy. Okay, and the specific particle is the photon. Photon. And this photon is a fake particle. Hypocrito. Meaning to say, he don't have his own power unless he will borrow the energy coming from the electrons. Okay, these electrons will lose, the particle in itself and give to photon. That's why this photon will become energized and it will be released as a ray, R-A-Y, or emission, so that we can see the light in our fluorescent, incandescent bulb. So that's going to be the responsibility of the photon because he borrowed from the electrons, the energy. Means the same. It's being energized because of the electron particle. Okay, it's gonna be like that. Okay? So that's it. Okay. Now, ang nuclear mga palangga akong hitan. Okay. What do you mean by nuclear radiation? Okay. Okay, radiation. It's more on nuclear transmutation. Transmutation. Again, what is transmutation, Sir Sotero? Okay. Nuclear transmutation, or let's say nuclear processes, nuclear operations, like that. Okay, meaning it involves nucleus. Okay, because of the word nuclear. Nucleus, meaning you will see to it that it's in the concept of an atomic theory, atom. Okay, like a circle atom. Could it be the John Dalton atomic theory? And could either be the Niels Bohr theory of electronic configuration and excited state and ground state of the energy level, like that. Okay? Then this is an atom, and then there's a nucleus here, like that, and composed of protons, neutrons, and electrons will be on the outside of the outermost shell of this nucleus. So imagine I'll just intensify this, but this atom is very small. For the purpose only of discussion, I make it big, okay, like that, since atom is the tiniest and smallest particle, okay, it's the tiniest and smallest particle of matter, okay, ganon. You get the point? And matter is anything that has weight and occupies space. Okay, nakakaloka, di ba? Ganon siya. Okay, now guys, there are two types of radiation. We have also two kinds of radiation. Sir Sotero, maglalahi ka rin Sir Sotero. Because in English, kind and type, there's a difference. When to say that it is a type, when to say it is a kind. Okay? So just like saying, what are the different types of chemical reaction? Okay, and just like saying, what are the kinds of chemical reaction? It's not the same, right? You get the point. Ganun siya. How can we know that? Okay. So kung sa may difference siya sa Bisaya, kasi Bisaya sa type, tipo, kind, hindo. Okay? Kasi Bisaya sa kind, classy. No, classy is class in English. Okay? Ang tipo kong babae, so type, right? Ang kind, hindo. And class is, ano siya? Class is classy sa Bisaya. And then, ang category is kategorya. Right? Sa Bisaya. So what is kind? Di ba, lisod? Okay? Wag lang. Surrender ako sa Bisaya. Okay, so two types of radiation yun siya. And two kinds of radiation, we have the ionizing radiation. Okay. Ionizing radiation and the non-ionizing radiation. Nandiyan na naman tayo. Okay? So, it's more on chemistry here. The kinds, okay? Ionizing radiation, like that. Okay. So, in here, we could not simply recognize when to say it is a type or a kind. Okay? All you have to do is, if it is a kind, it's referring to the energy. Okay, referring to the energy of a radiation. For example, ionizing energy, non-ionizing energy, meaning more on the energy it acquires. Okay, but in here, more on the general type, nuclear and electromagnetic, more on the general aspect. You get the point? But here, more on the energy, the behavior, something like that, the properties in this kind. Okay? You get the point? Ganun. That's what's only I understand. Okay, wala siya sa libro. Okay? O ako lang. O man. Diba? Okay? Something like that. Okay? I mean, not siya sa libro, but the way how I explain, it's not on the book. Okay? Because as much as possible, I will not be bookish. Okay, I can deliver my own interpretation and analysis of the topic. Something like that. Okay? So, now we give example for electromagnetic radiation. What are those? So this will fall to the electromagnetic spectrum. In the spectrum, you can remember that there's a frequency, there's a wavelength. So we have example for this electromagnetic radiation are, that's what I said earlier. For example, radio wave, just like a satellite for the AM and FM radio stations. That is also radiation, but it means sound wave. Okay, sound wave. The lightning also are under also radiation, but it is a light. Because guys, electromagnetic radiation is not risky and hazardous compared to nuclear. That's why we will not die if I will see the light. Get the point? This light of the fluorescent, this is also radiation. But why I will not suffer cancer or whatever? Because the energy is very low, the levels of radiation. But still part of radiation process. So we need to say, this electromagnetic radiation is having a lower energy. Okay? And this nuclear radiation is higher energy. Okay? It could penetrate to your cells, into your vital organ, like that. For example, just like a laser technology, like that, to determine the cause of your health problem. For example, if you have a in the bones, bone fracture, or whatever, like that, then or cancer, right? So it will penetrate to your cells. Imagine if it will penetrate to your cells, the X-rays, it will be more risky compared to the electromagnetic radiation. So electromagnetic radiation are acceptable, but constant also exposure to electromagnetic radiation will also cause disease, but not that really that fatal or risky. It will develop for how many years, something like that. Okay, but this nuclear radiation is very fatal. Okay, for example, you must have at least 2 X-rays in 1 year, like that. If you go beyond that, your respiratory will be having a spot, a hole, because this is very, very, very strong, shortest energy, right? It will penetrate to the cells of your vital organs. Okay, this nuclear radiation. Be careful with this one, okay? Ganon. Okay, so electromagnetic is lower energy and nuclear is higher energy. Okay? Ganon. Okay. So what is the difference between the two? So example of electromagnetic radiation, what ang mga radio wave, kaning mga sound na madulog sa cellphone, sa laptop. So these are also radiation, but in terms of a sound wave radiation. Okay? And then we have also the microwave. If you want to heat your food so that the food will receive heat and kill the bacteria and the microorganisms that try to alter the taste of your food, and the smell will become bad. To avoid that situation, you have to put in the microwave, right? So that it will not be rotten, it will not be taste bad, something like this. Also, microwave is also a radiation. Okay, that's why if you buy popcorn by using a microwave, or if you continuously use microwave in daily tool, then it can also create cancer in the future. Microwave appliance, be careful also. Okay, you get the point. So you need to take extra precautions for that also. Okay, for microwave oven, especially in making popcorn, something like that. It's very dangerous also. I read that in the one issue of the university, Harvard University Public School of Health, their magazine issue regarding microwave. Okay, microwave disadvantage to health, or some post health risk, like that. Okay, we have infrared. Infrared also, constant exposure to infrared also can cause cataract or glaucoma, the disease of your eyes. You cannot see clearly. Example, if you are staring at the heat of the sun, gazing at the heat of the sun and gazing too much at the light of the fluorescent, then it will also penetrate to your retina. You know retina in your eyes here, then it will create also glaucoma or cataract, something like that. So Infrared also is dangerous, but not frequent, or it will just appear also for how many months, how many years, like that. Not short length of time. Okay? Is infrared. Now we have the ultraviolet rays of the sun, UV. Okay, UV is also a radiation coming from the sun, the rays, right? For example, we have the ozone layer of the sun. The formula is 3 atoms of oxygen. These 3 atoms of oxygen will try to react the protium, deuterium, tritium in the process of nuclear, sorry, I have to remember, nuclear fission. In the process of nuclear fission, right? Yeah, nuclear fission. And then problem also. Okay? Because it's very hot, the UV. Okay, and then it can create also irritating of your skin, something like that. If you expose too much to the sun also, aside from the vitamin D, what I mean is that over kayo, nagbilad ka from 8 hours beyond. Because the heat of the sun also is good for vitamin D. What I mean is overexposure to the heat of the sun. That is ultraviolet ray. Okay, that's why there are a lot of sunglasses that is made of ultraviolet rays ingredient that we try to prevent, this ultraviolet to go directly to your eyes. Sunglasses, whatever. Okay, there's a shade, black shade. That's the purpose to block the ultraviolet rays of the sun. Okay. Now we have also the X-ray, visible ray na ta. Visible ray itong mga colors. It's not harmful, right? Itong red, orange, yellow, blue, green, white, blue. This is also radiation. Okay? Like that. And then we have the X-ray is the most fatal. Okay, X-ray. Shortest, okay, frequency, very strong energy, and the wavelength is very small. Like that. Okay? It penetrates to your organs and vital organs in the cells. It can damage your cells. But what is the advantage? X-ray's advantage is only designed to target only what is desired. For example, if your X-rays is related to the bone, and I know that what do you call this one? Studying the bone. I forgot the doctors studying at the bone. I forgot the term. For example, for the eyes, we have the ophthalmology, like that. And then for doctors assigning children, this is pediatrics, something like that. So there's a term also assigned for the bone, sa pangalan. And then for the doctor also assigned for the treatment of the disease and control of disease, pathologist. And then also a doctor that assigned in X-rays and radiation is radiologist, right? Or radio technician, the assistant of the radiologist. He is also a certified doctor. So there are different types of doctor in medicine, in different specialization, for example, kidney, lungs, like that, whatever, liver. Nakalimot lang jud ko isa to ang sa bone. Basta na rin na siya osteo, because is, a term attached to the bone. This we have osteoporosis, osteomalacia, like that. I think so it's related to that. Sa to ba? Sa to pa, osteologist. No. Okay, nakalawa. But what about August? Okay. So we have X-rays. Okay, ganon. And then we have the gamma ray. Okay. Now I will ask you a question. Which is more faster, the gamma ray or the X-ray? It looks like have the same property and characteristic, but who among them is very fast, the X-ray or the gamma ray? Okay, you can answer or not? Okay, we don't want to answer. The gamma ray is faster than X-ray. Okay, that's why we don't allow this to penetrate in our body. Okay, compared to the X-ray. That's why we use only X-ray rather than a gamma ray, because the gamma ray is very risky. Too much, seconds only. Ganon. Okay, but the X-ray it will take minutes, right? But this gamma ray too much, very quick. Okay, and they don't use this in hospitals or any technology because this is very risky and fatal, this gamma ray. So if you try to compare the X-ray and gamma ray is having more energy than X-ray, but they are the highest in the electromagnetic spectrum. Okay? You get the point? This X-ray and gamma ray mga palangga kung hitan. So any questions so far for this? And now we go to the nuclear radiation. What are those examples mga palangga? Okay, because this is part also of particle physics we need to discuss. Okay? And then we have nuclear radiation. Okay, by the way, ang katong last two, akong dimensions, actually guys, they are all electromagnetic radiation. Since to classify them, we need to classify according to their energy. Low energy will be electromagnetic radiation, higher energy will be the nuclear radiation. That's why the X-ray and the gamma ray is under nuclear radiation. Okay? Like that. X-ray, gamma ray, alpha ray, beta ray, ganon. Di ba? Dito po yung mga palangga akong hitan. Oh, ganon. And the gamma ray and the beta ray. Okay? Something like that. So these are all the nuclear radiation. As you can notice mga palangga akong hitan, your nuclear radiation are more as an ionizing radiation. Okay? Ionizing. So tinawag sa ng ionizing. Charot. Okay, discover the term ion. Okay, ions. What are ions? Positively charged particles, negatively charged particles. Then how can we achieve that? Through the process of reduction and oxidation, the loss of electrons and the gain of electrons. But specifically here in the ionizing radiation, that is really focusing on a high energy radiation, okay, that remove electrons from the atoms or molecules of different materials, substances, air, water, and any other living tissue. So that's the definition of ionizing radiation. So if you take the definition of non-ionizing radiation, it is totally the reverse. Okay, it is a type of radiation in which have a lower energy, then it will not remove the electrons from the atoms and molecules from any materials, living tissues, air, water, blah blah blah, so and so. Diba? So muna yung ionizing radiation, non-ionizing radiation. So more or less pala, mga non-ionizing radiation, katong mga electromagnetic waves na having low energies, up to ultraviolet rays only. Okay, radio waves, microwaves, infrared, ultraviolet, visible color rays. But for the X-ray, gamma rays, alpha ray, beta ray, gamma ray, like that, is all nuclear radiation and also ionizing radiation. Okay, ganon. Okay, nakuha na natin mga palangga, wala pa dyan, charots. Okay, now we go to an examples. We need to give examples, right? So that we can understand really, okay? So we are dealing with, let's say, ionizing radiation, right? So what are the examples of ionizing radiation? Okay? Diba? Ito na mga ray. Okay, ionizing radiation example mga palangga. Ionizing radiation example. Because it's very clear examples of electromagnetic radiation and you need to clarify aside from alpha, beta, gamma, X-ray, we need to clarify what are those another examples of ionizing radiation or nuclear radiation. Okay? So in here, we need to categorize the man-made and the natural radiation. Okay, man-made meaning artificial through discovery of human being, through technology, through apparatus, like that. We make it for a certain objective, like that. That is man-made. For natural, nobody make it. It's God-given immediately. Okay? Like that. So freely given by God. This is natural. This is natural resources. Okay? Like that. So this is natural radiation. And it is man-made radiation. There is a man-made radiation, guys. It's very costly. Okay? And it doesn't help to our environment sustainability and for the health of our environment. Okay? This one, this man-made radiation. Okay? And this natural radiation don't have a cost because it's appearing already, even if you don't buy it, something like that, whatever, okay? And this is environmental friendly because it's natural, okay? Or shall we say, the radiation is not too high compared to the man-made. Okay, just like the sun, right? Produces ultraviolet rays, blah blah blah, so and so. Radiant heat of the sun is radiation, right? But why we are not why we are not having a disease? Because it's controllable, okay, and at a low energy only, okay? Ganon. Get the point. Akong nabasahan guys, because the sun has its own control management of its own specific heat capacity. Nakakaloka? Really? Specific heat capacity meaning calorie per gram degree Celsius, right? Okay, the amount of heat energy required to raise 1 gram of a substance to 1 degree Celsius. That is specific heat capacity, right? You get the point? That's the definition. Okay, so nasa ikaw galing yung control management ang sana. So, kompleto siya sa mga staffs, supervisors, foremen, managers. He will try to control everything. He regulate everything so that the heat that will be absorbed by the human being is just enough for them to survive. Something like that. Or the heat that the living organisms, for example, the viruses, the bacteria, arthropods, arthropods, mga biological microorganisms. But there's a lot. Reptilia, mammalia, ganon. Even though they will receive the heat of the sun, they will not die. In fact, it makes them strong. Okay, because of the cellular respiration. Inhalation. They're also inhaling and exhaling the animals and the organisms, not only human being. We have the same process. Cellular respiration is applicable to living organisms, whether it is a human being or any types of animals here on Earth. Naging siya cellular respiration, meaning oxygen intake, carbon dioxide exhalation. Okay? Ganon, cellular respiration. Okay? Ganon. So, ang sun, dako ka siyang galit. Okay? Ganon siya. Okay. Diba? Kaya naman siya ozone layer. That's why we need to protect the sun. So the ozone layer will become thin due to the exposure of greenhouse gases, which are mainly the carbon dioxide, or shall we say a little bit carbon monoxide also, then problem. It will become thinner and thinner, then it will not hold already too much heat under the layer. So that's the time it will not be controlled. That's why we will not abuse our planet Earth. So that's already man-made, right? Because we abuse. Okay? So we expose a lot of gases into the, what we call this one? Chimney. Chimney, right? It is the gases will be there and will be going out in the chimney. Okay? Get the point? Ganun siya. Okay, natural radiation and man-made radiation. And now we break down also the man-made radiation. Sir Sotero, give me an example of a man-made radiation. Okay, man-made radiation. Anybody? Or artificial radiation? Man-made. Okay, like that. Okay, example. Ito na to siyang X-ray. Okay, X-ray technology by using laser. Okay, like that. Actually, this is a scanning. Okay, this is a scanning technology, meaning imaging through sections of your vital organs by using the penetrating power of this ray. Okay? Penetrating power means it will be going there inside your body and then go through your bones, to your blood vessels and your organs, something like that, to the specific target only as per design of your laser technology and X-ray. Or else if that is not designed for a particular organ, then problem. Right? So that's gonna be like that. Okay? So this is man-made. One. So laser is light amplification, simulation, emission, radiation. Okay, laser technology. Okay. Sometimes for the eyes also, you need to remove the cataract through the laser technology also. I think a lot guys na sa kidney side, mga stones, kidney stones in the gallbladder, or whatever, it will be also using laser. A lot, di ba? Okay, so number 2 will be the CT scan. It's gonna be the brain, right? Okay, so, or the head. This is a computed or computerized tomography. Tomography is is a term of medical science that tells you the study of imaging by sections and sectioning parts by parts in the internal body parts of the human being by using a penetrating power such as an emission of a light or X-rays, light, light. Okay, and absorption of the light through your cells of your internal organs, body organs, vital organs, whatever, like that. To really point out, what is the cause of the health problem, so that we can aid what is the best treatment for that. Okay, so tomography coming from the word usually tumor. Okay, tumor is the local term for tomography, and it's being attached only to tomo, that's why we call tomography. So usually for tumors, okay, it will reduce the length, reduce the thickness of your tumors. Okay, if you are noted to have first stage cancer of your liver, something like that, so it's gonna be like that also. But in the CT scan, it's more on the brain, something like that. Okay, dito po yung mga palangga. Number 3, we have the fluoroscopy. Okay, fluoroscopy is more on using fluorine, because this is fluoro. Using fluorine as an element to be combined with your radiation. Okay, to penetrate also to internal body organs, because these are all medical diagnostic techniques. Okay, meaning it's used to diagnose health problems to the patients in the hospital. So medical diagnostic technique or procedures. Okay, like that. Ganon. So what else? We have also the nuclear medicines procedure. This is more expensive. Nuclear medicines procedure. So in here, all our particles are being used to treat your diseases. The electrons, the protons, the neutrons. No medicines, only the particle will try to solve your health problems. That's why nuclear medicine procedure. And this is very, very costly. Okay, of all. These are all man-made radiation. By the way, this the MRI, blah blah blah. And for example, ultrasound. It's not really that risky. Okay, compared to this four. MRI, magnetic resonance imaging. Okay, to the point. It's also a diagnostic test used by our doctors. Okay, to treat diseases in the head or in the brain, something like that. I'm not really that sure. Or in the bone, in the skull. Like that. With the point skull, S-Q-L-L. Right? Okay. Ganon. Okay, that's man-made. And now we go to the natural. Okay, natural radiation. What are those natural radiation, mga palangga umitad? Okay, this is radiation from Earth. Okay, radiation from What are the example of radiation from Earth? Okay, from Earth. This is the very famous, the solar radiation, sun. Okay, ultraviolet rays of the sun, infrared of the sun, radiation of the sun, like that. Name it, all are radiation. Okay, it depends on the levels of the amount of energy that your skin will be absorbing. Right? The process of absorption through your pores in your epidermis, the outer layer of your skin, right? And there's a lot of pores, millions of pores in your outer layer skin, epidermis, and it will go directly to your internal body organs, like that, to absorb this heat of the sun. Sometimes bad, sometimes good, because this can help also for the conversion of vitamin D. Okay, like that. Get the point? So it depends on the situation. Okay, solar radiation, but the risk is not too high. Yes, you will exposed all the time. You're sleeping in the land without house. Okay? That's the time you will be dying because of solar radiation. Okay? But since all of us have house to sleep, apartment to sleep, so how can we be absorbing the entire heat of the sun in 24 hours? Right? So it's gonna be like that. So we have solar radiation and cosmic radiation. Cosmic is more on the celestial bodies and heavenly bodies in the universe. You know, universe, outer space. Okay, like that. Okay. Now we have the radiation from the, radiation from the, materials or buildings. Ganon. Okay. There are materials, guys, that will emit radiation. Okay? For example, your example only, guys, for the purpose of conversation only. So, for example, you have a technology that is made of radium, okay, ganon, polonium, katong radioactive materials sa periodic table. Okay? This is highly radioactive. Okay, it will have a decaying process. So that's why radiation through materials and from the building structures. It depends on the situation, what you are using, elements there, metals there, whatever, it will create also. You get the point, mga palangga umatag? Okay. And then we have also the terrestrial radiation. Terrestrial, it's more on the rock, right? Rock formation, yung ganun. Terrestrial. Okay, like the, terrestrial radiation. Ganon. Okay. And then you have also radiation from the space, outer space. Okay? There's a lot there. The galaxy, the Milky Way, ganun. Okay? Dito po yung mga talaga kumitan. Okay, terrestrial radiation is more on, example for this guys is ano siya? Okay, radon. Okay? Radon gas is very deadly also at a higher level. Radon gas is a radioactive gas found in rock formation. It will also release higher amount of radiation. Radon gas with an atomic weight of 222 gram per atom in the periodic table. Okay? Something like that. Basta mga 200 plus ganito, mga palangga kumitan, more or less, they are radioactive. For example, radium, 223, gano'n, di ba? Okay, na uranium, 236, gano'n. Okay? Then francium, 226, gano'n, di ba? If you can still remember. Okay, and then cesium, 142.4297 atomic weight, gano'n. Okay, cesium, iridium, okay, 133, iridium, cesium, gano'n. Okay, polonium 244, plutonium 244, or polonium 209. The atomic weight and atomic masses of radioactive elements are usually 200 plus. Okay? You get the point? Huge atomic mass. Okay? You get the point? So that it will undergo a nuclear transmutation, usually by nuclear fusion. Right? From big molecules to smaller molecules. Okay? And the nuclear fission is also the reverse, small molecules to big molecules. And that is the process of the sun. Okay, the helium gas released by the sun is through the process of nuclear fission. Ganon. Diba? Okay? Ito po mga palangga unitan. Okay, that's it. Any questions so far? Kumukhaon ako. Charot. Diba mo na siya yung mga radiation. Later we'll be solving problems, guys, with regards to Stefan Boltzmann law of radiation. Okay? Katong yung mga kuan, thermal conductivity, mga ganun, diba? I could still remember that in physics. Bye-bye, God bless everybody. See you later. I hope you like it, and you can subscribe to the channel if you want. And you can click the notification bell for some of the stuff that's of a singer, eternal voice. Okay, bye-bye. Oh, di ba? Ah! Ganon.